Now that we have all our parts to create the logic probe circuit, now we can start building it. But before we get started, let's go ahead and review our items. We have these small signal diodes right here, the LEDs. I chose red and green. I'm going to be using red for low logic level and green for high logic level. And here we have the hex 040, the hex inverter, the 7404. And as you can see, there's small lettering imprinted on the device body or the IC body. Now you do have to use an external light or like a cell phone light to really see those letters. It's hard to see it with normal daylight. So as you can see, it says SN74HC04N. This is the hex inverter. As you can see, it has a 74 and then HC04. So that's how we know it's a 7404. I have my 470 ohm resistors and my 2.2K ohm resistor. So following the diagram and following the figure 1-5 image in the lab manual, I'm just going to go ahead and use that as reference to connecting the whole circuit. Now the first thing I'm going to do is connect my positive source, and then my negative, now I'm ready to connect my chip onto the breadboard, and we're going to connect the chip so that it's centered across this bridge or this gap divider. Now recall that the pins are numbered on the IC. As you can see, there's a small groove right here. This is called a notch. So to the left of the notch, that is pin number 1. To the right of the notch, I believe that's pin number 14. So as we can count the pins, this would be pin number 1, 2, 3, 4, 5, 6, 7. So the bottom one next to left of the dot is number 7, and right of the dot is number 8, 9, 10, 11, 12, 13, 14. So that's how we count the pins. So I'm just going to go ahead and insert it. It does require a little bit of pressure, but be careful not to bend the pins. So the next thing I'm going to do is connect all my components. So I'm going to start off with the items connected to, the components connected to pin number 1. So I see there's 2 diodes. And as I said, I'm directly following the diagram. So I want to make sure that the black side of the diode represents the black bar in the diode symbol. It is a little difficult to see, but there is one side that is black. So we want to make sure that we put the same black bar in the same orientation that is in figure 1.5. This 470 ohm also is connected to pin 1, but it's also connected to ground. Now I'm going to connect my other 470 ohm resistors. Now this LED, you can see one side is longer than the other and one side is shorter. This is a positive side and the shorter side is the negative. So the longer side is known as the anode, and the shorter side is known as the cathode. So I'm going to connect in the same orientation that we need to have it set up, similar to the circuit diagram in figure 1-1 in the lab manual. So that means that the anode side is going to be connected to the resistor side. So I'm just going to go ahead and put the long side to the resistor and the short side away from the resistor. Oops. And the same thing with the other LED. This is the long one. It may be difficult to see on the video, but it is longer, and this one is shorter. So I'm just going to go ahead and connect the longer side to the same side of the resistor. And I have the last 2.2 k ohm resistor. Now I can make all the connections in the circuit. Now that I've completed all the connections for the logic probe circuit, I'm going to use a blue jumper wire to act as a probe. So I'm just going to go ahead and connect that now. And the probe is connected to this point on the circuit, where on the same row that the two diodes connect. So I'll be using this now to touch certain pins or other jumper wires to act as a probe. Now that my circuit is complete, I connected my Analog Discovery 2 to my computer, turned on waveforms, went to supplies, and set the positive supply to 5 volts. Now I can complete part B of the lab manual. So by testing it, by touching the ground, I should send a low logic level, which should make the red LED turn on. It's already on, and it stays on, so that's good. So now let's test it with the 5 volt or high logic level. The green LED should turn on. As we can see, the green LED did turn on. Therefore, our logic probe circuit is working correctly. Now we are ready to move to part C of the lab manual. In part C, it states that use the probe to test the inverter that is between pins 3 and 4. This is inverter 2. So pin 3 is the input of inverter 2, and pin 4 is the output of that inverter. So I'm going to use this orange jumper wire to connect to pin 3. And as you can see, with the other end of the jumper wire, I can either assert it low by connecting it to ground, assert it high by connecting it to the 5 volts, or leave it open where it's not connected to anything. As you can see, it's at open state right now in an invalid input. Yet the red LED is the red LED is on. But let's go ahead and connect our logic probe. You can see that now it's switched to green. This is an invalid input because we have neither high or low asserted in pin 3. So now I'm going to go ahead and assert a high in pin 3 by connecting this end of the orange probe to the 5 volts. And you're going to see that it will change from green to red because the inversion of a high logic level is low, and the red LED represents low logic level detected by the probe. Now I'm going to connect this end of the probe, the cable, to assert a low logic level, connecting it to ground. And as you can see, the green LED is on, and that makes sense because the inversion of a low logic level is high, and the green LED represents the probe detects a high logic level. Now that completes the lab 6 for the logic probe circuit.